Hello, and welcome to Order of Magnitude Up, the second in a series of introductory tutorial videos for Ms. Moser's physics class at Beaver Local High School. As with your other videos, I'd encourage you to take notes, and there is a short quiz that follows, linked at msmoser.pbworks.com. So, with that, you know the drill. Let's get started. Let's start off with the basic question. What is an order of magnitude? An order of magnitude is a way to express the number of powers of 10 that a number contains. So, 1 has an order of magnitude of 10 to the 0. There are no powers of 10 within 1, and 10 to the 0 is 1. What about the number 10? Well, the number 10 contains 1 power of 10. It has an order of magnitude of 10 to the first. 100 has an order of magnitude of 10 to the second, and 1000 has an order of magnitude of 10 to the third. These are pretty easy examples. Now, let's look at some more interesting ones. So orders of magnitude, or as we could say, are always written as powers of 10. Thus, 10,000 has an order of magnitude of 10 to the fourth. Well, what about the number 12,000? What's its order of magnitude? Also 10 to the fourth. What about the number 518? Well, we could say that 518 has an order of magnitude of 10 to the second. And that's a very good, very rough approximation. But sometimes in a case like this, we include a very shortened, very abbreviated portion of the original number. So we might say that 518 has an order of magnitude of 5 times 10 to the second. We'd never go any further than that first place, though, so we'd round that number. 518 has an order of magnitude of 5 times 10 to the second. We'd never say 5.2 times 10 to the second. That's getting too specific for orders of magnitude. Remember, these are broad, general approximations. What about 987? Well, if we look at it, it's in the hundreds. So that would be 10 to the second. But if we really look carefully, this number is much closer to 1,000 than it is to anything in the hundreds. So we would say that this has an order of magnitude of 10 to the third. Because if we were going to put it in the form of the first number with a power of 10, that 9 would round up, and we'd have 10 times 10 to the third, or 10 times 10 to the second. That gives us an order of magnitude of 10 to the third. Be careful with numbers that are very, very close to the next order of magnitude. So, this is fascinating, right? But why do we need to know this? When will we use it? Well, orders of magnitude are used a lot in physics and some other sciences to do quick estimations and reasonability checks. Let's take an example. You've been asked to multiply these two numbers together with no calculator, or you just need to do a quick check on the ballpark figure for the answer. So, can we do an order of magnitude estimation for them? Certainly. And there are two distinct approaches here. So, first of all, we could do the roughest order of magnitude estimation and say, well, this number has an order of magnitude of 10 to the fourth, while this number has an order of magnitude of 10 to the second. So we think that our answer should be somewhere in an order of magnitude of 10 to the sixth. That's a very rough approximation. Let's do a slightly more nuanced approximation. If we take an abbreviated portion of the first number, we would get 7 times 10 to the fourth. And if we do the same for the next number, that 4 would round to a 5. So we'd get 5 times 10 to the second. Okay. Now, what would that give us? Well, 35 times 10 to the sixth. Or, if we wanted to be a little bit more correct about it, since we're no longer estimating, we're working with the number we got as the result of our estimates, we could 3.5 times 10 to the sixth. If we wanted to stick with our rules for order of magnitude, we could even say 4 times 10 to the seventh. I made a mistake there. I moved the decimal and forgot to change my power of 10. So, we could say 4 times 10 to the seventh. What's the actual answer to this multiplication problem? Drum roll, please. 35,409,726, or 3.5 times 10 to the 7th. Wow, that's not too shabby. What a handy tool. Okay, so great. If we're stuck with a really big math problem and no calculator, we can use an order of magnitude estimation to get a ballpark for our answer. But what else can we do with it? Well, we can use orders of magnitude to make quick estimations of things around us, and this is something we do a lot in physics. Let's imagine an order of magnitude estimation of the number of students at Beaver Local High School. We know that we have 4 times 10 to the 0 graduating classes. We have 4 graduating classes. Now, approximately how many students are in each of those classes? Well, we know that the number of students in each class is certainly greater than 100, or 10 to the second, and we think it's probably less than 2 times 10 to the second. So we can do this as a range. If we assume that there are 10 to the second students in each class, we get an order of magnitude estimation of 8 times 10 to the second, 4 times 10 to the second students. If we take the higher estimate of 2 times 10 to the second students in each of the 4 times 10 to the 0 classes, we come up with an estimate of 8 times 10 to the second students. So that gives us a range where we can say that the number of students at Beaver Local High School is probably between 4 times 10 to the second, larger than that number, and smaller than 8 times 10 to the second. In fact, if you look at our student body population, it runs right around 600. Not too bad. So what if you wanted to estimate something like, the height of the football stadium? How can we go about doing that? Well, we certainly know that it's more than order of magnitude 10 to the 0. This thing's definitely more than. So if we want to estimate the height of the football stadium, we know that it's got to be more than 10 to the 0. It's more than 10 feet high. We certainly know that this is not anywhere near 100 feet high, so we know it exists somewhere in the order of magnitude of 10 to the first. Now, if we want to get a little bit more specific, would you say it's 50 feet high? Probably not. So we might go ahead and say 2 times 10 to the first, or 3 times 10 to the first. That's a pretty good estimation. Similarly, you could estimate the order of magnitude of a dog's life, 10 to the first, or the order of magnitude of a school year, 2 times 10 to the second days. It's important to have not only the order of magnitude, but what kind of units we're talking about. A school year might be 2 times 10 to the second days, but it's certainly not 2 times 10 to the second years. So specifying that unit really does make a difference. That's it for now. Go ahead and take your quiz, and you'll have one more video to watch in your series. We'll use orders of magnitude for some pretty heavy-duty estimations when we get into Chapter 1 in physics. Take care.